Hey guys, this video is part 2 of the homework about arc length on page 687. So I'm going to start on question 29, which gave us this diagram. And basically the question is to find the radius. And so you can do the same type of thing that we've done before. List out your given info. So what I have so far is the length of LM. That's 42.56. And then I also have the central angle, which is 240 degrees. So once you have that given information, it makes it a little bit easier to go ahead and plug into your formula. The same exact formula that we've used for any question that has arc length. So the arc length compared to the circumference should be the same ratio as the central angle out of 360, which makes sense. This is like the part out of total, so that's just a ratio. So now I'm going to take my given information, plug in the length of arc LM, plug in my central angle, and then I can do my cross products to find my circumference. Okay, so to isolate the circumference, C, I want to divide out this 240 to both sides. So when you hop on your calculator and evaluate 42.56 times 360, divide that by 240, you end up with a circumference of 63.84. So you would have to remember from our previous lesson that the circumference is the same as 2 pi times the radius, right? Circumference, r is the radius. So if I want to find the radius, I'm going to substitute this formula for circumference. So I want to get r alone, I need to get rid of this 2 pi. So I'm going to divide it, and that simplifies to about 10.16. This is question 31 from the same page, 687. This one a lot of people had questions on. So what I would highly recommend you do on this question is to highlight the sections I'm about to explain. So in this diagram, they told us that the distances from one of the circles to the other circle, all of these distances I highlighted in yellow are 5. So I know that that's part of the perimeter of this whole figure. So I've got 5, 5, and 5, which gives us a total of 15. So I know that the perimeter is going to be at least more than 15. Then we've got these little pink sections of our circles, which I put together here. So if I take a third of each circumference, that's going to total up to pretty much be one entire circumference of one of the circles. So if I can figure out the radius of one of these circles, since they're all the same, I can find the total distance of that pink distance, which is the circumference of one circle. And once we have that, we could just add the 15, and then I have the total perimeter. So in order to find the radius, I want to focus on the bottom two circles here. So the distance from one center to the other center is 5, which means that each of these distances has to be 2.5. because these are congruent circles. So that means that I have a radius of 2.5, and therefore I can find my circumference. So in case you don't remember the formula for circumference, 2 pi times radius. I'm going to plug in 2.5 for r, which simplifies 2 times 2.5, 5 pi. So now I've got the total distance of this pink arcs here, which makes the one circumference, plus the yellow parts, which is 15. 5 pi plus 15 simplifies to 30.71. Question 33 from page 687 was a little bit tricky because you had to find two variables. You had to find x and also y. So I'm going to break this question into 2 steps. Step 1 is going to be just finding x. Okay, so the way that we're going to solve this problem, I noticed that x is part of this angle. So if I could figure out what this angle measure is, this central angle, then I can figure out what to set this expression equal to find x. So the first thing I notice is they do give us the other central angle, this 225. And I know that the total degrees inside of a circle for all the central angles together would be 360. So I'm going to take that total, subtract that yellow angle, the 225, which means that this pink central angle has to equal 135 degrees. And so I can take that and set the expression with x equal to 135 and just solve for x from there. So subtract my 15, that gives me 120 equals 2x. Divide my 2 on both sides, that gives me 60 for x. Now, step 2 is going to be to find y. So the first thing that I notice about y is that it's not part of an angle measure. So it's part of this arc length. Okay, so I'm going to go back to that formula that we've been using to find arc length. Okay, so if it's easier, I think, to just kind of label on here so you can keep track of what you're doing. So the arc length AB compared to the entire circumference is going to have the same ratio as the central angle over the 360 degrees total, right? So another thing that was given to us in this question was the radius of 8. So if I know the radius, I could find my circumference by knowing that circumference equals 2 pi r. Okay, so I'm going to set up my proportion by plugging in what I know. I know the length of arc AB. I know my circumference because my radius is given, so I'm going to plug that in for circumference. And my central angle, 135. So now I'm going to do my cross products like we did on all the other questions, and then I'm going to start to simplify. So step 1, I've got y minus 3 times pi times 360 degrees equals the 135 times 2 pi times 8. Okay, so 135 times 2 times 8 simplifies to this number, 2,160. And then I can start to move stuff to the other side of the equation to get y alone. So I'm going to get rid of this pi and this 360. So I'm going to divide both of them on both sides so they go away totally over here. And on this side, pi's cancel out. 2,160 divided by 360, we're left with 6. And then all I have left to do is move the 3, so I'm going to add 3 to both sides. Therefore, y is 9. Hopefully this video helped answer your questions that you had lingering from this homework assignment. If you still need some help, please come see me to set up an appointment.